All right, here's another problem from the kinetics module, and this involves the activation energy given a rate constant at a specific temperature and wanting to know the rate constant at a second temperature. So the equation that involves the activation energy, you got to be a little careful writing it out. It's the log of, and you can either do K2 over K1 or K1 over K2. That part doesn't matter as long as the rest of the equation works. So log of K over K equals minus E sub A over R. And then with the minus sign, it's 1 over T1 minus 1 over T2. If I don't have the minus sign, then I would put 1 over T2 minus 1 over T1, or I would put K2 over K1. And when you're solving for activation energy, if you accidentally flip-flop your K's or your T's or leave off the minus sign, you'll numerically get the same answer for activation energy. It just will have a negative sign, and there's no such thing as a negative activation energy. But when you're solving for one of the rate constants, you have to put them in the right order or else you will get completely wrong answer. We've got the right answer pulled up here for this particular set of numbers just to make sure I'm doing it right. So we're wanting to know the rate constant at this temperature. So what we're solving for is one of our K's. I'm going to call that K1, which means that temperature is T1. That means this K is K2, and that temperature is T2. Which set you call 1 and set you call 2 doesn't matter as long as you keep the set together. R is in joules. Our activation energy is in kilojoules, so I've got to change one or the other. Let me rewrite this. This is 15.30 kilojoules. The times 10 to the first power means I move the decimal one place. And so it's 15.30 times 10 to the third joules multiplied by 1,000. So let's write our activation energy in joules. Again, I could have written my R in kilojoules. That part doesn't matter. All right, to solve for this, I need that K1, but the first thing I'm going to do is solve for the log of K1 over K2, get a number, keep it in my calculator, and then I'll go on and do the next algebra step. I just find that mathematically a little easier. So the log of K1 over K2 is equal to the negative of 15.3 times 10 to the third divided by 8.314. Let's make sure I get my T's right. They're already in Kelvin, or else I would have to change them. T1 is 7.540 times 10 to the 2, so that would be 754 Kelvin, minus T1, 3.100 times 10 to the 2, so that's 310 Kelvin. You should be punching this in along with me just to make sure you're getting the right thing. Then you can scream at the video and tell me if I get the wrong thing, except for you won't ever see it because I'll scrap the video and try again. And you know I shouldn't talk while I punch this in. I am getting a positive 3.4956. Let me punch it in one more time. I like to, especially because I talked through it. All right, I'm getting exactly the same answer. I do end up with this negative sign cancels with this value is negative because it's a smaller number minus a bigger number. So I do end up with a positive numerical answer on the right side. Sometimes it's positive, sometimes it's negative. Just be warned. In this case, it is a positive. That means my log of K1 over K2 is equal to 3.4956 ... I've got that number stored in my calculator. So the next thing I'm going to do is I'm going to take the inverse log of both sides, which is my second function log, and that leaves me with K1 over K2 equals the inverse log of this. Oh, and I need to make sure it's positive. Shift ln, that is 32.9726 ... And then to solve for K1, I multiply both sides by K2. I've got this number in my calculator. I come up here and grab that K2, and K2 is 1.6 times 10 to the minus 5 times that 32.97 ... So times 1.6 times 10 to the minus 5. I end up with K1, hallelujah, equals to 2. I get, here, let me write this out. I get this, and to two significant figures, it would be 5.3 times 10 to the minus 4. Please note that this is a larger K value than the other one, so this should coincide with the higher temperature. The higher the temperature, the larger the K value. This is a good way to check to see if you got your sign wrong up above in the first step. So at the higher temperature, at 754 Kelvin as opposed to 310, I should be getting a larger K value. And I did. And that's, oops, and that is the right answer as indicated above.